And then question B is the same premise. If you take a look at the two, binomial, there's no common factor between the two. However, if you take a look at it, it's a difference, and this is a perfect square because the square root of this is just 2x, and this is a perfect square, square root of that is just 7. So that means this came from two brackets that look identical, except one has a plus, one has a minus, sum and difference. Square root of that is just 2x, so that's what goes here and here, and square root of that is just 7, so that's what goes here and here. Again, you know this would be the answer because if you re-expand it, the middle terms will cancel out when you have a sum and difference, two brackets that are the same except one has a sum, one has a difference, always ends up in a difference of squares. Okay, so that should bring back some information, recall some information from you for last year. Now, let's take a look at these ones here. Again, I'm going to pull up a blank screen, but it's very important you know how to expand something that looks like this. 2x minus 3, or let's say plus 3 all squared. The way you would do this, the long way, would be to actually do this. 2x plus 3 times 2x plus 3, because 2x plus 3 squared means this bracket times itself. And then if you apply FOIL to this, multiplying everything by everything, 2x times 2x is 4x squared, 2x times 3 is positive 6x, and then over here, multiplying the 3 times 2x is another 6x, and 3 times 3 is positive 9. So, just notice what happens, and this will always happen when you have something squared. 2x all squared gives you 4x squared. The 3 squared gives you the 9. But then you will have 2x times 3, which is 6x, but you will have two of them in the middle, always. So this ends up being 4x squared plus 12x plus 9. Now it's very important you understand that a binomial squared always ends up in a perfect square trinomial. Always a trinomial. Please do not do this on a test, because I've seen this time and time again, as any other math teacher has seen. Kids see this and they say, oh, I know how to square that. 2x squared is just 2x times itself, is 4x squared, and then 3 squared is 9. But that's wrong, absolutely wrong. And I will guarantee you still people will think this is right somewhere on their test. Please do not do this. You should always understand a binomial squared always ends up in a perfect square trinomial, which is 3 terms. So, my question is, how do I go from here straight to the answer? And from your homework last night, to go straight to the answer, yes, the first term actually is 2x squared, which is 4x squared. That times itself. The last term, yes, is 3 squared, which is 9. But the middle term, how do you get that? The middle term is always going to be 3 times 2x, which is 6x. Double it, because you'll have 2, 12x. So this is how you expand that very quickly. Okay? So how do you know that something is a perfect square trinomial? How do you know something's a perfect square trinomial? That's the other question. You know something is a perfect square trinomial, or at least you know something is weird as soon as you see a perfect square at the front and a perfect square as the last term. As soon as you see that that's a perfect square, the square root of that, you can take the square root of that is just 2x, and as soon as you see this is a perfect square, the square root of that is just 3, there is an opportunity that this is a perfect square trinomial. Why would you want to know that? Because if you were given this, it would be better to factor this perfect square trinomial, knowing that it came from something that just looks as simple as that, rather than perform decomposition, because decomposition may be the worst method for factoring ever. So how do you check the middle term? Again, the square root of that is 2x. The square root of that is 3. 2x times 3 is 6x. Double it, it's 12x. So yes, this is a perfect square trinomial. And yes, it comes from that. What is that? It's a binomial squared. Square root of that is just 2x. Square root of that is just 3. This is embedded in doing your completing the square problems. Whenever you complete the square and you come up with a perfect square trinomial, you always end up in one of the final steps, the second last step, factoring a perfect square trinomial. So that's just a little background to knowing if something's a perfect square trinomial. So for instance this, the first thing you look at, this is 4x squared plus 36x plus 81. The first thing you always want to look at is there a common factor? No, there is not. So then you say, oh, this is a complex trinomial, so let me go use decomposition. Well, I guess, yes, you could use that. However, I noticed something. I noticed that that's a perfect square, because I can take the square root of that as just 2x. And that's a perfect square. I can take the square root of that as just 9, right? The square root of this is 2x, and the square root of this is just 9. So, knowing that, there may be a possibility that this is a perfect square trinomial. I have to check the middle number. How do you check? The square root of that's 2x, square root of that is 9. So 2x times 9 is 18x. 18x, if I double it, it's 36x. So yes, this is a perfect square trinomial, and no, I do not need to use decomposition. I can go right to the answer because I know a perfect square trinomial comes from a binomial squared. Square root of that is just 2x, square root of that is just 9, and there's a positive sign in the middle. So this would be the final answer. If you re-expanded that, I promise you would be that trinomial there. Last one here, again, take a look at this, 9x squared minus 30x plus 25. First thing I check for, common factor. There's no common factor here. So then, it's a complex trinomial. There's a 9 in front of the x squared, so do I use decomposition because it is a complex trinomial? No, I actually first am going to see if this is a perfect square trinomial because I noticed that I can take the square root of that. It's just 3x, and I can take the square root of that, it's just 5, right? Square root of that is just 3x, and square root of that is 5. So this is a possibility for a perfect square trinomial. 3x times 5, 15x, double it is 30x. So guess what? This is a perfect square trinomial. I'm going to label it as that, and I'm going straight to the answer. No decomposition needed for me. So it comes from a binomial all squared. Square root of that is just 3x. Square root of that is just 5 with a negative sign in the middle because the b is negative. So I promise you that will be, if you expand that, it will be that trinomial. So again, first things, common factor always. Then take a look at what type of trinomial you're dealing with. Is it a simple trinomial? Use PSI. Is it, and you can go right to the answer, is it a complex trinomial? Use decomposition. Or is it a special trinomial? Is it a perfect square trinomial? If you've noticed that the first and last terms are perfect squares, then there's a possibility that it is a perfect square trinomial. Not all trinomials are like that, obviously. And then, is it a difference of squares? You also have to know that. So those are the four main ways of factoring. Again, is common factor, simple trinomials, complex trinomials using decomposition, and then special products such as difference of squares and perfect square trinomials.